Good morning to all. Myself Preeti from R&D Engineering College. So today we'll see a topic from Unit 5 other transducers. One of the other transducer will be strain gauge. So we'll see about the types and different characteristics of strain gauge. So what is actually a strain gauge? Strain gauge it is nothing but we simply we can call it as a passive transducer. So passive transducer means a transducer which produces n number of changes in the capacitance, inductance and resistance. So we call such transducers as a passive transducer. So a strain gauge is one such example, and also we can tell LVDT as an example of passive transducer. So LVDT is nothing but linear variable differential transducer. So this strain gauge or this passive transducer, it converts a mechanical displacement into a change of resistance. So for that variable change of resistance, this comes under variable resistance transducer. So the main part in strain gauge is a thin wafer like a device will be present in that. Okay, you can see this is the strain gauge. You can see the thin foil connected. The thin foil like a structure plays a major role in the strain gauge. So this is the structure of a strain gauge, you can see. So these are the end loops for each and every, like the foil, it will be surrounded by the end loops. It has a strong grid attached with it. It is how much ever the length it is, that much ever the end loops and the grids will be very strong in the strain gauge. And these are the upper end loops and these are the lower end loops and this is solder tubes. So it is tightly encapsulated with the outer ring. Okay, so this structure mainly depends upon the foil. Okay, the foil, how it will be varying means it will be completely depend upon the shapes, size, and how it is varying for different type of applications. So this is the main thing about strain gauge structure. Next, this is the working. The strain gauge, it is actually connected, you can see here connected to a Wheatstone bridge. R1 wire, R2, R3 and you can see a R wire resistance is connected and this is the strain gauge. So now what happens? Actually, the changes that happens, the change in the resistance will be determined with the change in the current. So therefore, we give a particular concept called gauge factor to determine the terms of the characteristics of this particular strain gauge. So it is defined as a unit change of resistance by unit change of length. So del R by R by del L by L. So the unit change, whenever there is a change in the length, there will be the change in the resistance. So I've already told you in the structure, however long, how much ever long it is, that much ever the accuracy will be very good. So it depends upon the gauge factor del R by del L by L. Change in the length to the change in the resistance. So types of strain gauge. There are different types based upon principle of working. It is mechanical, electrical and piezoelectric. Based on mounting, it is bonded strain gauge and unbonded strain gauge. Based on construction, it is foil strain gauge, semiconductor strain gauge and photoelectric strain gauge. So mechanical strain gauge. So mechanical strain gauge is nothing but whenever we give any strange or strain anything, the mechanical energy will be converted into a electrical energy. The change of the resistance will be given by the strain applied on that particular material. So this is mechanical strain gauge. Example of it, or this would be the instrument used for mechanical strain gauge. Electrical strain gauge. Here mainly what is the thing is the electrical wire plays a major role. So this electrical wire will be stretching accordingly whether it should be small or long. It increases from one end to another. When it is been increased from one end to another, the resistance will be changing. So this comes under electrical strain gauge. And the third one is piezoelectric strain gauge. So as we everybody know, piezo means press. So when I'm going to press, these are the piezoelectric material and this is the wire present there. The wire, when it is going to press under this particular piezoelectric material, there will be a change in the resistance. So this we call it as piezoelectric strain gauge. Next, it is bonded strain gauge and unbonded. So bonded means one particular capsulation will be there. Okay, in that particular capsulation, this strain gauge will be made insidely. It will be present. So the leads and the wire grid will be very thick, so that no disturbances will be there. So this is bonded. Whereas unbonded, you can see it can be easily taken out and it can be easily replaced. So when we compare to bonded and unbonded, unbonded is very important. Why? Because it is also widely used. Why? Because when there is any changes, we can easily remove it. It is like a movable element. We can change it and we can also reinsert it. So therefore, most of the industry they use unbonded strain gauge. Next, foil strain gauge. It is very similar to a normal strain. Any number of foils will be bounded on it so that the capsulation will be very strong that external factors couldn't affect it. This is foil strain gauge. Semiconductor strain gauge, which is nothing but here they will be using piezo resistors. Okay, a very small strain also will be giving a big change here. So that is what semiconductor strain gauge. And it is mainly semiconductor, if we talk, means it is mainly made up of silicon or germanium. According to the type, according to the material which we are going to use, the changes in the variation of resistance will be high or low. Okay. The next one is photoelectric strain gauge. So a thin wire which conducts light, okay, which has a capacity to like traveling of light will be possible here in piezoelectric strain gauge. It uses a light beam, two fine gratings, and a photocell detector to generate the electric current. Okay, so this is photoelectric strain gauge. So the advantages and disadvantages are, advantages means there is no moving part. Very rarely it will be there. It is very small and inexpensive. Whereas the disadvantages will be it is non-linear. As I've told you, the foil will be it always varies, right? So it is obviously it is non-linear and it need to be calibrated. So these are the advantages and disadvantages of strain gauge. Hope you understand. Thank you.